Here we go. We have a question: minimum numbers of operations to make elements in an array distinct. You are given an integer array. We need to show that the elements in the array are distinct. To achieve this, you can perform the following operation any number of times. We will remove 3 elements from the beginning of the array. If the array has fewer than 3 elements, we need to remove all the remaining elements. Note that an empty array is considered to have distinct elements. We need to return, our task is to return the minimum number of operations needed to make all the elements in the array distinct. So if we have given this array, so first if my array is this, and if I remove these 3 elements, so all the left elements, all the remaining elements, we need to make sure that all the remaining elements is distinct, right? But not in this case. So we need to remove one more portion. First portion is this, so we will remove one more portion. So the remaining elements is this. Is this distinct? Yes. So we need to remove 2 portions. So the answer in this case is 2. In this example, we have given this array. So if I remove my first portion, does my remaining array have all the distinct elements? No. So I will remove the second portion, and in the second portion we only have 2 elements, so all the elements is removed. Now all the remaining element is empty, remaining array is empty. Now this is called distinct, right? So the number of operations required is 2. In this case we don't require any operation, right? So the answer is 0. Let's build the approach. Suppose we have given this array. So I have taken 2 test case, one is this, second is this. This test case I have taken from the example only. Then we need to make sure that we remove the first portion, we remove this portion, we remove this portion, and all the elements should be distinct, right? So why not start from backwards? So if I start from backwards, what I will do, I will make sure that if I choose an array, if I choose an element, so I will choose this element, that this element is not seen before. So this element is not seen before, so just consider it. This element is also not seen before, just consider it. This element is not seen before, just consider it. Now this element is seen before, right? So we need to remove all these elements, we need to remove these many portions, right? So if I divide the array into 3 portions, so 3 portion, 3 portion, 3 portion, and what this index tell us, it tell us that till this point we need to remove all the elements, right? So this element is 5, so if I divide into 3 portion, we got 1. So it means we need to remove 1 portion, but we also need to remove one more portion, so we need to remove 2 portions. So I will just add plus 1, right? So it means I need to remove 2 portions, and that's how this will work, right? So what if my 3 is here, my 3 is here, so what will happen in that case? So I will reach this element. Is this element seen before? No. So just consider this. Is this element seen before? Yes, this element is seen before, right? So we need to remove this portion, right? So if I do 4 by 3, it means I am dividing my array into 3 portions, we got only 1, and I also need to remove my current portion, so that's why this one is added. So I need to remove 2 portions in total, so first portion and second portion. And if I remove 2 portions, my remaining arrays is distinct. What if this 4 is reached, is seen before? So I need to remove this portion, so it means 3 by 3, which is 1 only, I need to remove one more portion. So this portion is removed, this portion is removed, so we need to remove 2 total portions. So let's talk about this example. This element seen before? No. Is this element seen before? No. Is this element seen before? No. Is this element seen before? No. So just add it. This element seen before? No, just add it. Is this element seen before? Yes, this element is seen before. So what I will do, I will just take 2 by 3, which is my current index, by 3 portion, which is the following criteria to remove the elements, so it will give me 0. So if I add plus 1, it means I need to remove one portion. I need to apply the operation one time, right? So what if I got 5 5? What will happen in this case? So first I will reach this. Is this element seen before? No. Is this element seen before? Yes, this element is already there in set. So I will use set data structure. So this element is seen before. So it means I will write 6 by 3, which is 2 only. So I will just add plus 1. It means this portion is also removed and 2 previous portion is removed. So that's how this approach will work. Let's code this. So I need n. I need backward traversal and I need a set. So set dot add nums of I, and if this element is already there, so just return I by 3, then plus 1. Else we don't need to remove any portion, so just directly return 0. Let's run this and I hope this will work. In between, let's talk about time and space complexity. So in this code, my time complexity is order of n and my space complexity is also order of n. I think my internet is not working. So we have successfully solved this question. I will provide the code in the description box. If you guys have any doubt, feel free to ask in the comment section. Thank you all for watching.